So somebody came to you, you are a project manager, and that says, oh, this is something you can do. It requires $100,000 worth of initial investment. So this is the money going out in year 0. And then says rate of return is 10%. Oh, good. But inflation is happening in economy, prices are increasing, right? And which would in some way impact us, and these prices are increasing at 4%, right? So inflation in Canada is actually fairly stable, right? We are either into 2% region, 3%, 4% recently, right? Is a 2%, right? So we are not highly kind of inflationary economy. Our inflations are fairly stable, I would say. So the rate of inflation is steady. This way also I can put it. So which is good for us, right? But it is given as 4%. So you have to take into consideration this. And once you start that, right, for example, it is a machine, it will produce something and you will sell it. First year you make a revenue of 20,000, second 50, third again 50, fourth 25, because this machine is depreciating, and fifth year you won't be able to make any revenues because that is what the life of that product was, which you created with 100,000 4 years life, right? Sometime we sell our car after so many years and it is all junk. Nobody pays us anything, or we don't need that, right? So it is like that. So now question is, will you undertake that project? You would say, look, this is a little mathematical. How would I do that? But the good thing is we know that we have to see net present value. And net present value means we will do these calculations, right? 100,000 is outflow and these are 4 inflows for 4 years. Given in the question, we calculate the net flow. Here 100,000 is going and 20 is coming, 50 is coming, 50 is coming, 25 is coming. And this is discount factor, right? And discount factor is 1, right? This year's $1 is $1. But if prices rise and value of money depreciates, then next year it is worth 0.87, right? And third year it is worth this, right? Discount factor, like look, the word is discount in itself, right? So the value, so this is discount factor, right? So this is discount factor. The value of money is getting discounted because of inflation and because of this present value thing, right? Now, here we do what? Here, 100,000 times the discount factor gives us this number. 20,000 times discount factor gives us this number. 50,000 times discount factor gives us these numbers, right? And after 4 years, project is worth nothing. The machine that we were using to create these revenues is gone. And then we total all these numbers. And this is net present value. And if it is positive, then you will undertake that project, right? So it means by doing this project, you are adding this much value to your company, which is good, right? So after 4 years, your company would be valued more by this amount as compared to when you started with. But if this number is negative, it means it will depreciate the value of the firm. You won't do that activity which depreciates, right? You won't do something on your house which reduces its value in 4 years, right? Why would you do that, right? So this is the concept. That now this is the same question. This is the same question, right? I did it with Excel sheet, right? So these are, for some reason, these are years. Of course, you can see that these are years, right? And then these are inflows only, right, where the money is being made from revenues, right? These are inflows. First year there is no inflow because we have not started, but there was outflow, right? So outflow, for some reason I have to make a separate column. This is how it worked for me, right? So there was no outflow in up further years. And this is net outflow, net flow of cash, right? Inflow is 0, outflow is 100,000, net is B2 minus C2. It means this column minus this cell minus this cell, right? So I did it for every other, and this is net flow, right? For this method, you need the net flow. And then this count factor is 1, and then this, and then this, and this. And I did not copy it from book. I created it through this formula, if you see here. Right, in formula bar, if you see, I created that formula. That was my kind of research. Equal to, bracket starts 1. You can take a picture of that and try it if you know Excel or have it on your computer, I mean. Slash 1 plus 0.1 is 10% required rate of return. This one is required rate of return, right? And then this is 4% inflation. And this is a caret symbol, which means raised to power, right? In formula, there was a raised to power, and I do the raised to power for first year as A3, right? And then just once you do it for one formula, you can drag it and this will stay for. So this is net present value factor I calculated. And then as I showed, this into this gives me this. Here, look. This is D3, 20,000 times present discount factor times with that, this is giving me net present value. So I got the net present value of all the 4 years. And then what did I do? I have summed up all these 5 values. And this is actually the exact answer. Probably the book gives you round figure, but my answer came out 4567.8. Right? So this is that answer. Net present value I calculated here. Right? So, I mean, this is now dynamic. You can change it. For example, another guy comes to you and says, okay, Mahesh, this is actually 10% required rate of return, but in 2020, inflation has fallen to 2%. So 10 plus 2, buddy, you have to do 12%. I have formula here. Look, I can change this formula to 2 and it becomes 12%. I click check mark, and this is my net present value, 9193.80. So it means if we are in a less inflation economies, our present values are less, which means our projects add more value because inflation does not eat it out. Right? Inflation means out there, the raw material is expensive and everything is expensive. The labor is like having higher hourly rates, and that is why we are able to add less value. But if everything inflation falls and everything is less expensive, we add more value. So this is a dynamic program. Right? So this is a dynamic program or model, and you can modify it. At 3% inflation, 10 plus 3, 13, required rate of return, for example, remains same. Then this is 6,841.93. At 4%, the original one I am now shifting to, it was this answer, right? So this is net present value formula in the Microsoft Excel, right? So this way we can use these models or Excel sheet to kind of do the calculation. And once you got the gist of it, then you can like just start playing with it. So if you paid attention, I have done it 2 ways. One is with using by using these 2 columns, and actually I can do that without using these 2 columns also, the green ones. I can directly use NPV formula. NPV 14% rate, D3 to D6 are the values I'm adding, and I'm discounting those, only the revenue part, and then I'm adding to that the initial outflow, which is already in negative. So even if I delete it, this answer would stay same. But these are detailed calculations, right? So, I mean, kind of you start playing with it on a later date. So these are not very difficult things. Kind of you have to spend for this method at least, I mean, at the most, I would say half an hour or so, kind of. So this is net present value. It is live method as I showed. If you change anything here, answer would change. Answer would change, right? If my initial cash flow is more than 100,000, maybe I don't know, maybe this net present value even gets negative, and I let me make it 110,000, and then yeah, this is now in trouble, negative. So I won't undertake that project. Here the net present value is in minus, and I can even show that one because these signs come, these number signs come, but if I hover over them, still I see the good number, or if I have to extend the call and this number comes up, but it is in red. So I got into red area, but at 100,000 of initial investment, it was working all fine. Yeah. So this way, this is like any number anybody gives you, you fill those numbers and you get the answer, right? So that way, but when you do it manually, then you have to kind of spend the time. Thank you for your attention here. I have to go back and share our slide here, right? So this number was in manually, we got 4567, but actually with the model, it came out to be exact number of $4,567.80. Thank you. Keep on watching and learning.